Good morning, class. Welcome back. Today we are going to make a little foldable together, and then the foldable is going to contain some problems for you guys to do today. So the first thing we need to do is we need to make our foldable. Now, you will need to print this out from Google Classroom. If you can't print this today, you can make one of these out of just a regular piece of paper, but then you'll need to copy down the drawings. So I'm just gonna show you this kind of slow so you can see what's on it. If you need to stop the video, slow it down and just copy that onto paper. It might be better to copy it after you get it all folded. So, but here you can see what all goes on it. Okay, so here's how you make one of these foldables. The first thing we need to do is we need to fold this piece of paper into 8 boxes. So I'm gonna fold it in half this way. Do not worry about what's printed on there. We don't need to worry about that till we get it all put together. So I'm folding it in half. I did a hamburger fold. Now, it's gonna be really important that these creases are really creased. Okay, so I'm just running my finger along it on the counter to make it really creasy. Okay, now I'm gonna make another fold. You can actually fold it either way, but I'm gonna make another hamburger fold. I'm gonna fold it the opposite way that I just folded it. And all I'm doing right now is just dividing this paper into 8 boxes. And again, I'm gonna run my finger over that a lot to make it very creasy. The crease is what's gonna make it come together a little better in the end. I'm even using my fingernail to get that creased. Okay, and then I'm gonna make one more fold like this. Now you wanna try to make these folds kind of neat. I'm just running my nail over it to make it very creased. Okay, and since I want it to come together pretty easy, I'm just folding it back and forth both ways because I want that crease to be really nice. And I might even go back and forth this way. So all I'm doing, guys, is getting 8 boxes. So you don't have to worry about which direction you're going. I'm just looking to get 8 boxes. Okay, so I'm gonna unfold it. And you should see that it's divided into 8 little pages. And if you wanna make any of these creases better, you can. You can even flip it over and do that on the other side too. Just make these creases nice. Okay, so right now your paper should be all opened up. You should see 8 boxes like this. Okay. So the next thing I'm gonna do is I'm gonna fold it again just so I can put a cut in a certain place, okay? So I'm gonna fold it in half, hamburger fold again, just like that. And see, there's a fold on this side and there's an opening on this side, okay? I'm looking at that word trigonometry. I'm gonna take a pair of scissors and I'm gonna put a cut right here, but I'm gonna stop in the center, go all the way to the center. So I'm gonna cut right above the word trigonometry on that fold, and I'm gonna, do not cut all the way through the paper. Stop right in the middle. Stop right there. Okay, so I went all the way to the middle. So I folded it in half again after I flattened it all out. And so I folded it in half and then I cut right above the word trigonometry and I stopped in the middle, okay? So right now there should be a hole in the paper. I'm gonna open that back up again. Hole in the paper. Okay, so open it back up. All right, this thing's about to become a book. Okay, so the last thing we're gonna do is we're gonna do a little folding and squashing, okay? So after you get it all opened up and you see a hole in your paper, fold it hot dog fold this time, but leave this opening open. Okay, so I folded it hot dog fold, but I'm leaving this open. And so what you do is, since that's open, kind of like an accordion, you know, I'm just gonna squish it together, and then putting the word trigonometry on the top, I'm gonna fold it back, and I'm gonna squash it down. If yours isn't on the right page, okay, if you did that and you're somehow here or something, just keep turning the page until trigonometry is on the top, the word problem's on the back, and you just squash it down. And you have this. Okay, so watch. If you turn the pages, you've got yourself a little book. Like this. Word problem on the back. Okay, if this bothers you right here, you can put a little tape on that one. Because see, this one, there's a fold. And this one, there's a fold. But you could put a piece of tape if you want to on the ones that are open. You don't have to, of course, because it holds together. All right, put your name on there. I'm gonna put my name. So you guys put your name on there. Normally I say, because if it gets lost around school and I find it, I'll get it back to you, but it doesn't look like that's gonna happen anytime soon. So let's talk about what this book is. All right, so this is the book of problems for reviewing trigonometry. And this is just the cover. There's nothing to do here. On the cover, you'll see that I have some labels on these two triangles. And so if you remember from before the break, we were doing trigonometry. And to understand trigonometry, you have to know some definitions, the definition of sine and the definition of cosine and the definition of tangent. And those definitions use words like opposite and adjacent. So in this picture, this is just showing a picture that this side across from the right angle is the hypotenuse. It is in both triangles. So that definition doesn't change, and it doesn't depend on what angles we're talking about. Hypotenuse is always across from the right angle. But these terms opposite and adjacent, they change. See, this is opposite and adjacent, this is adjacent and opposite. And they change depending on what angle we're talking about. So in this top triangle, we're talking about angle A. So this is the opposite side because it's across from angle A. Down here, we're talking about angle B. I know that because of these right here. So the opposite side would be down here because it's opposite, it's across from angle B. So these terms, opposite and adjacent, all depend on what angle you're talking about. If you're talking about angle A, this side's the opposite. If you're talking about angle B, like we are down here, then this side would be the opposite. So it all depends on that angle. Now, hypotenuse does not depend on A and B. Hypotenuse is always across from the right angle. All right, so there's nothing to do on the front. In the middle, there's some work to do. I'm gonna do some of it, and then your job is to come back and do all the rest that I don't do, okay? This is just a definition page, okay? On the top and on the bottom, I wrote you a little memory device for remembering what sine and cosine and tangent mean. Now, I learned it like this in school. So my teacher, Miss Thoreen, taught us to memorize SOHCAHTOA. So stands for sine is opposite over hypotenuse. This term in the middle, ka, stands for cosine is adjacent over hypotenuse, and toa stands for tangent is opposite over adjacent. So this is sine, cosine, tangent, and its definitions: opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. But there are some people who write it like this, and some teachers and tutors that I've seen work with my students write it like this. It's still SOHCAHTOA. It's still that memory, little memory acronym, but they wrote it to look like it would look: opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So it's just another little memory strategy. All right, so all we're doing on this page is writing those definitions. So the sine of an angle is the opposite side over the hypotenuse. So this page is just for the definitions, and I want you guys to come back and do these two. Or as I go through this video, you can pause the video and you can do the rest before I before I go on to the next page. So you can either wait till the end and stop the video and do all the rest, or you can pause the video, do the rest, and then do the next page with me and keep pausing and doing each page as we go along. That's up to you. All right, the next page, so this is just for definitions. The next page is for doing these trig ratios. Okay, so over here is going to be the definitions. So the sine of A, here's A. The definition of it is opposite over hypotenuse. So in relation to angle A, this would be the opposite side. And the opposite goes on the top. So 7 goes on the top. And then in this drawing, here's the right angle. The right angle points to the hypotenuse. This is the hypotenuse. Hypotenuse goes on the bottom when you're doing sine, opposite over hypotenuse. So that would be 7 over 25. And then I want you guys to do cosine of A and tangent of A. So on this page, you're going to be writing these ratios, these fractions. I think I'll do sine of B for you. And then you guys are going to do cosines and tangents. Okay, sine of B. So if I was talking about angle B, 7 is not the opposite. In relation to angle B, 24 is the opposite. So across from B would be the opposite side. So this would be opposite over hypotenuse. The hypotenuse is still 25. So sine of A is 7 over 25. Sine of B is 24 over 25. So you guys are going to do the rest. Again, you can do it at the very end after the video's done, or you can pause it and do that now. Okay, so when this copied, I really don't know how y'all's came out. I have no way of knowing that, but here's how mine came out when I printed this from Google Classroom. I lost my X there, and I lost some of my directions, so you may want to fix that. Okay, so on this page, we have 3 problems, and they want us to actually use the trigonometry. So we're going to use the trig to find missing values. So when we did these problems before the break, remember I would circle the angle. I'm circling the angle so that I can, draw my attention to it. And that angle determines what kind of problem this is, whether it's a sine problem or a cosine problem or a tangent problem. So here's how you know. It all depends on what sides are labeled. So see how this right angle it points to the 15. That means this is the hypotenuse. I'm going to write a little hypotenuse here. That's what 15 is. 15 is the hypotenuse. The side across from the 51 is blank, so I'm not going to label that. That would be the opposite side because it's across from the angle, but it's blank. So I'm not putting an opposite there. And then that means if that side's the hypotenuse, 15, and this blank side's the opposite, that means this must be the adjacent side. So this is adjacent. Well, that's what tells me what kind of problem this is. I have adjacent and hypotenuse. If you forget the definitions, look back here. The one that has adjacent and hypotenuse, A and H, that's a cosine problem. So that's how I know this is cosine. So I'll write cosine. And you always write the angle next, cosine of 51. Cosine of 51 degrees. So whether you write sine, cosine, or tangent, the angle always comes next. And then the definition of cosine would go over here. Definition of cosine is adjacent over hypotenuse. Okay, now I just have to solve the equation. You will absolutely need a scientific calculator to solve this. You cannot solve this without a scientific calculator. So we're going to put that over 1 and we're going to cross multiply. So 1 times x is 1x. And then 15 times cosine of 51. 15 times cosine of 51. You always put the normal number in your calculator first. So 15, you can put times or you can just put cosine. Times cosine 51. You get about 9.4. See, if you did 15 cosine 51 without putting the times in there, the calculator knows to multiply that because there's no other operation in the middle. And it does it for you. It's 9.4. So x is approximately 9.4 units long. That's how tall that line is right there. Okay, so I want you to show this work right here, and I want you to show this work right here. So when I check back on this, or when you show me this later, I should see equations here and solutions. Equation, solution. So you guys are going to do the other two. All right, next one. This time we have missing angles. How to set up the problem, though, is exactly the same as the one I just did. So here's the angle. Circle that because I'm trying to put my attention there. And then I have to look at what sides are labeled. So in relation to that angle, I have the side across from there. This is the opposite side. And then the right angle is pointing to that 15 right there. So that's the hypotenuse. I don't need to label this side because it's blank, but that side is adjacent to the angle. It's right next to it, but I don't need that. Okay. So I have an opposite and a hypotenuse, and if you forget the definitions, you can always go back to the definition page. Opposite and hypotenuse is a sine problem. You can see it from here. Opposite and hypotenuse is a sine problem. So you write sine. The angle always comes next, even when you don't know the angle comes next. So sine of x is equal to opposite over hypotenuse. So this is our equation. All right, so normally I cross multiply. So normally I would put a 1 over there and I would multiply 15 times sine of x. But the reason I don't do that here is because you cannot find the sine of x. There's no way to do that. See, if you type in sine in your calculator, that blinker blinks at you and says, okay, find the sine of what? And we don't know what, because that's unknown. So whenever the variable is right there, whenever the angle is the variable, then what we do is we use that right there. Do y'all see that? Sine -1. We're going to use that to get rid of the word sine. And to get to there, we have to push this yellow button. All right, so to get rid of the word sine, we need sine -1, and that will cancel. And whatever you do to one side, you have to do to the other. So this is what we're actually typing into our calculator. We're typing second sine to get this, and then we're typing in this fraction. So you grab your calculator, and you do second sine, and it's going to say this, sine -1. That's what I need. And then I'm going to type in this fraction, 12 divided by 15. 12 divided by 15. And you get this, 53 degrees. Angles, they like them rounded to the nearest whole number. So use that right there to see if this needs to change. Since that's a 1, that stays a 3. If that was a 5 or more, then that would change to a 4. So this is 53 degrees. You guys are going to do that same thing with this one. So I should see an equation here, and I should see work. Just to clarify, here's what I actually type in the calculator. Second sine, and that opens up parentheses. It actually puts a sine -1, and then you type in 12 divided by 15. So that's what I actually typed in the calculator. They call these calculator keystrokes, because these are the keys you type. Okay, last one. Last one is an angle of, I don't think we did angle of elevation yet. I'm going to fill these in for you. It says you're building a ramp for skateboarding from a 36-inch board. This is the board, because this would be the ramp. Here's your skateboard, right? So this is the ramp. It's a 36-inch board. And it says that you want the ramp to rise at a 20-degree angle of elevation. So that's this angle. And I think I'll move this 36 to a better place. And the question is, how tall is the vertical rise of the ramp? Let me put the 36 right here. This is the vertical rise. This is horizontal. This is the vertical line. This is what they want. So here's your reference angle. All right, so you're gonna set up a trig equation and solve it. All right, so your homework today, or your work for today, is to solve all the rest of these that we did not do. Okay, and then what I would like for you to do is take your phone and film it with you turning the pages just like this. Turn it kind of slow so I can see all the pages. And then I want you to submit that video, turn that video in the assignment section of Google Classroom. So enjoy, guys. This is a little review of trigonometry today. Y'all have a great day.